it's kind of amazing. The more we do these, we've talked to a bunch of people that we work with doing AMR, all in environmental areas, and yet no one has had the same job. Every single person is doing something slightly different. And that's why we all still have to keep working on it because,
Yeah.
each little question, each little expertise is different.
Welcome back, everybody. This is Tales of the Resistance again. I'm Mara Zaltz. I'm on staff here at I Am Responsible, which is a national team working on outreach around antimicrobial resistance. I'm going to be joined on the pod today by our regular co-host, Beth, as well as one of the researchers on the Camarade's team who we've been interviewing in this series, this short series of podcasts. So for those who weren't able to catch the last pod where we interviewed the PI of the Comrades Project, we were talking to Michelle Superior, who it was at Iowa State, and she was telling us about how the whole project kind of came together and what they're hoping to learn about how antimicrobial resistance moves in the environment and what are the potential human health impacts of it being in streams in agricultural rural areas. And we're also learning a lot about how they measure for that and some of the problems and also some of the breakthroughs that they've been having on this project so far. So in today's podcast, we're talking with Moriah Brown. She is a graduate student. So this time we're going to hear more of the sort of on the ground, hands-on, somebody who's doing a lot of the direct work of collecting samples in these streams and then figuring out, in her case, she's also involved in some modeling to put together the data that she's been collecting and trying to discover what it means. So hopefully you enjoy this conversation and that you'll stick around for the rest of the interviews in this series as we continue to talk to folks working on antimicrobial resistance in environmental settings and learn more about how they do their work and also what they're learning. And we hope that you really enjoy this. So I'll go ahead and transition us over to our previously recorded interview with Moriah Brown.
My name is Moriah. I am a current PhD student in the Department of Civil and Environmental Engineering. I am mostly doing watershed monitoring. We have our site location is Shell Creek. That is about 2 hours northwest from Lincoln, Nebraska. It is a agriculturally dominated watershed, and that is where we're getting our samples from to look at antibiotic concentrations and the antibiotic-resistant bacteria and genes.
How did you get into AMR? Was there like a event that you like had someone you knew that had AMR, or how did you get interested in working on it?
I had really no experience until working on this project, not even really knowing what AMR was until this project. So I think my first year as a PhD student, that's where I really got the most experience in learning about what it is and why it's important and why we're doing research on it.
Uh-huh. Well, I hadn't heard about AMR either beforehand. Some people have known about it for a long time, but I don't recall. You got into this project. Was it just because you were working on a PhD and that's what they had available? Or were you like, I wanted to do this idea?
It was, yeah, really, because I'm working on a PhD and this was the project available. But in general, I do enjoy it. It is in the line of work that I kind of already wanted to do, which was looking at emerging contaminants. Previously, I still work on this as well, or microplastics. So before, my experience was looking at microplastics in agriculturally dominated watersheds. So this is kind of that same realm of new emerging contaminants in an agriculturally dominated watershed. So,
Do you have an agricultural background, or you're just like really interested in how those two things, like food and the environment, are kind of coming together there?
Yeah, I actually have no agricultural background at all. I grew up in Knoxville, Tennessee, and then in undergrad, I went to Howard University in Washington, D.C., so definitely nowhere near an agricultural background. But how I got into it is I actually did the summer research program here in Nebraska the summer before my senior year of college. And again, I was working with my current advisor, Dr. Shannon Bartell Hunt. Um, on another microplastics project that just, yeah, focused on agricultural watersheds. But really what got me into looking at emerging contaminants in these types of watersheds, because they're generally, I feel like, overlooked, especially like microplastics as an example is like we're mostly looking in urban areas, the ocean, cities. No one's really looking at these agricultural areas that still can have a big impact, especially with the sources. It's just harder to define the sources, and same with the antibiotics. Is like we assume it's all coming from manure application, biosolids application, but sometimes it's a little harder to pinpoint exactly how it's getting into our surface water in these types of environments. So,
Well, I feel like since it's the Meet the Team one, we need to know a little bit more about you, Mariah. What is your what is your favorite part of doing this research so far? What do you get the most excited about?
I think when I first started this project, my favorite part was definitely the field work. I really like enjoy just being outside in general. Um, um, I think fieldwork, being able to see the sites physically, how they change over the year, the season, that's
Hmm.
the big part of fieldwork I like is like going, because we were doing sampling every 2 weeks, so I really got to see throughout the season. So we had sampled probably starting in April, depending on temperatures, weather, and all of that, all the way till October. So seeing different land practices change, seeing the crops grow, then get
Hmm.
harvested. They're leaving cover crops if they're tilling. Seeing all that change while I'm out in the field, also being able to compare what I saw with my own eyes to what results I'm getting based off of like, oh, we had a higher concentration this week, and I was like, oh, I remember they had just harvested, or there was a big rain event that day, so we had more runoff. So it's always that was always my favorite part is the actual field work, and then being able to compare what I saw with my own eyes with the results that I'm seeing afterwards.
Can you tell us more about like the what a field work or a field work day would look like? Like how many people went, how long was it, how far did you have to drive, that kind of stuff.
Yeah, so for our field days, they'll start pretty early in the morning. Um, we would be heading out around 6 or 7 in the morning. It'd be 2 or 3 people, including me. So, not only was I sampling for the Comrades project, I was also sampling for some microplastics, um, at the same time. Um, so what we would do, we had 4 sites we would go to, take about 2.5 hour drive to get to the first site. We would go to the site furthest upstream first, and then make our way back downstream. Um, so that and how that looked for me actually sampling, either putting on depending on how high the water was, putting on boots or full waders, actually getting into the stream, collecting the sample. We would also take like flow measurements. We would bring nitrate and phosphorus strips out to measure those as well. And then we were also measuring like the depth and width of each stream or portion of the stream that we were sampling from.
Hmm. Do you have any good stories, either funny, something funny that happened or something horrible that happened that you could tell
Uh,
during your sampling and or whatnot during the project?
I think I think the worst thing that happened, not really, it's not really bad, but it was in the spring, and it was, I guess, we were getting a lot of like severe weather that week and tornadoes and stuff, and we were trying to dodge the storms, but we luckily finished sampling, but on the way back did get caught in one of the like tornadoes on the way,
Oh,
driving on the way back, and so got stuck in the hail and the wind. Couldn't really see anything, and it was starting to flood as we were driving back. But
oh no. On the interstate it was flooding?
it was it wasn't even the interstate. One of the county like dirt roads. So
Oh no. Oh, I bet that was a little bit nerve-wracking.
a little bit. But
Did
I'd
you
rather
see?
be done with the sampling and in the car
Yeah.
than it had happened while I was still outside.
Yeah. Well, you're afraid you're
Yeah.
gonna get stuck though?
A little bit because it was just a minivan and
Uh-huh.
I
Did
don't
you
know
see
how.
the tornado close by?
No, it
Wondering
was
if it's gonna go closer?
it
Sometimes you
was
see people drive on the interstate and the tornado is so
yeah,
close.
it was like all bright and sunny, and then we saw like clouds, and then it got pitch black, and then just pouring rain and hail. So it was
Mm.
Mm. Can you back up just a sec? I mean, we're a little bit involved with the project, but not within the research capacity. So maybe you can kind of tell us within your words how you would describe the overall objectives of the project, and then you can kind of contextualize where you fit in to those goals.
yeah. So the couple of goals for the project, one was watershed monitoring. So that is what I work on the most with the sampling, collecting the samples and running those samples in the lab. And then there's also watershed modeling aspect of it that I also am working on, and that is using the program SWAT Plus, which is the Soil and Watershed Assessment Tool. And in that part of the project, we are wanting to build a watershed scale model that will help predict the concentrations of the antibiotics, antibiotic-resistant bacteria and genes, and also kind of help inform land management practices to better understand how these contaminants are moving within the watershed. And then the last piece of this project is going to be risk assessment model, which I really don't work on at all, but is big part of this project, very important because we want to connect everything with the watershed monitoring to the modeling to this risk assessment to better understand how what we're finding in the watersheds impact human health.
Can I ask a little bit more about, so sounds like you're working on is this big modeling. It's bringing the results together and trying to get like, what does it actually mean to have this much chemistry in your water? What does the real world impacts? And that's, I don't know, you haven't, how you feel about this, but for me, that's the most exciting part is like, what
Yeah.
does all the data mean in terms of real world implications?
I haven't gotten that far yet, but right now I'm working on calibration of just the flow of the model. But that is the goal, is that we're taking the data with the concentrations we've been finding in the watersheds, and using that data to, help build the model so it can predict, future concentrations.
For someone who, like myself, who doesn't really know anything about modeling, could you kind of give a rundown for, like, let's say the listener who's like, I have no idea what they're talking about. What's modeling?
Yeah, so it is kind of putting what we have in the physical world, what we observe in real life, and taking those observations, those data, putting it into this computer model that will help us understand how what we're seeing in real life, how that actually would change in the future based off of climate change, just weather patterns. We have our current observations that are inputs that give us new outputs of what could happen in the future just based off of, what
Okay.
climate change.
You're
And
doing a
then,
prediction.
prediction. And then the good thing with SWAT Plus is that we can add different land management practices to the model that would be used in real life to help understand how the concentrations of whatever contaminant we want to look at might change. So like adding buffers um, to a field in between the stream and whatever cropland is there, how that might change the concentration from AMR running off from the field into the stream, how these different management practices might reduce the concentrations that we're finding in the environment, or if we do this instead, will it increase? Stuff like that.
Yeah, that's interesting.
I'm just like how I always think of it, and I'm not a modeler. I haven't done a lot of this kind of thing, so correct me if I'm wrong here, Moriah, but I always think of it as like the modeling component of doing one of these projects is trying to create the relationships or understand and predict the relationships between the actual observed variables and everything else that you know, like
Yeah.
about that site, like temperature, time, date, what's going on in the landscape and all that stuff. And like you create some kind of hypothetical, usually mathematical relationship between them. And then you kind of test it. And that's the like building of the model part, is understanding the relationships. And then with something like SWOT, so for people who haven't heard of that before, that's like it's a water quality model. So it's already an existing big computer model that has been used and developed and tested many, many times. So those, you can kind of assume that those relationships are well understood, and then you can kind of add in your own new stuff with the AMR thing and not have to recreate everything from scratch, right?
That is, yeah, correct. But unfortunately, SWOT Plus doesn't model AMR yet. So that is
Yeah.
the kind of the challenge we're facing with that. But essentially, yeah, everything you said is basically how the modeling aspect works. So from previous studies, I believe they used the pesticide module that is already available in SWOT Plus, and yeah, regular SWOT as well. So I think that is generally where people have started, at least with trying to model antibiotics as well in AMRs, starting with that pesticide module. But yeah, it's hard. I did get to visit the developer SWAT in Texas about 2 years ago. But he is currently having to, for us to be able to model the AMR, it would be a lot of recoding, adding new code to the model. So basically creating whole new modules and parts.
Well, that's an interesting thing to consider for our audience. You know, a lot of times we talk about science as in the process, you know, like how we do science. It, you know, it's two steps forward, one step back. Even with things like SWOT, which is well established within research and modeling fields, it's incomplete for all the things that we would be interested in. And it's a lot of rejiggering and uncertainty.
Tell us more about, I'm sure it's still early in the project, but so you've run some of the modeling. What have been some of the results? Have you seen anything interesting or surprising?
So on my side, I really I'm just at the calibration stage. So for modeling, we have the model set up with just getting like our land use, elevation for the area, stuff like that, and getting our weather and observed data together. And then right now I'm at the calibration phase, so which there's a couple of things that we had to calibrate. We had to first calibrate like the hydrology, so flow, and then next we would do like sediment, and you would also do your nutrients, so like your phosphorus and nitrates. So right now I'm at the flow part of the calibration. Schwab at Iowa State has gotten a little bit farther in his calibration for the Black Hawk side of this project. So he's gotten his flow calibrated. He has not gotten, I believe, good results yet for the antibiotics yet. I think he's still working on trying to get that calibrated and figured out. But yeah, his model's more comprehensive than mine right now, since I'm still working on the flow calibration, which it's not good yet right now because it's still model performance is still unsatisfactory, unfortunately, but we're still working on it.
That's
Are you
nerve-wracking.
done with the sampling part, or are you continuing on this last over a year?
We are done with sampling here for Shell Creek. I think Iowa State is still sampling a little bit in their watershed. But yeah, we are done here for sampling Shell Creek.
And you don't know that much about what the results have been in terms of differences between the two?
We have kind of similar, or found similar concentrations in the antibiotics. So with the grab sampling, our concentrations that we're finding are pretty low, and sometimes, at least I know for Shell Creek, the first year we were sampling, a lot of our results we had no detects, but we think it's because of the sampling technique. We're just not able to detect those very, very low limits with grab sampling. That's why we started doing POSIS as well the second year. I believe that the POSIS samplers will be able to detect lower limits that you just aren't able to with the grab sampling method. And so generally we had similar concentrations, the fact that kind of lower or no detects, a lot of no detects that first year. So yeah, a little similar trends. I think we both had higher concentrations of monensin, which is an ionophore that is used in cattle or ruminants. So that trend was kind of similar, where compared to the different antibiotics that Buffalo was testing for, that was one of the ones that we would detect the most or had the highest concentrations.
But just for context, that's not like ionophore is not one that would be used for human medicine. It's only used for animals. Yes.
Right.
Maybe you don't feel like you have a great sense of what all the possibilities are, but maybe if you've thought about like what you hope to have an impact on, with your career and the work you're doing in this area on the AMR problem, and what are you most concerned about for how we collectively are dealing with it? It doesn't have to necessarily be in your field, but it could be something else around AMR that you've heard about.
Yeah, so I first would be excited to, be able to have a model that predicts the movement, and then also have the antibiotic resistant bacteria and genes involved in that model as well. And I think if we're able to do that, it will be the first model ever, because there's really no other literature that has a model that is able to predict these things yet. So currently, and I think it is because, again, that module's not set up in SWAT yet. And so that's the biggest thing I look forward to, is seeing how that works out, how quickly we might be able to get that done. Also looking forward to some of my other work as well, along with the microplastics. I look at how the microplastics and antibiotic-resistant bacteria interact with each other as co-contaminants. So that's something I'm pretty excited about as well, and seeing more research come out about that, because we already know that microplastics like further transfer like other contaminants like heavy metals, and then they are apparently also can do the same with the antibiotics and antibiotic-resistant bacteria and genes. So I'm excited to look at that. And yeah, for the future is like, I think we just really need more education on it. It's like we talked about earlier, is like people aren't really exposed to what AMR is until, if they go to grad school or if they're, you're wanting to be in the medical field. That's the only other place I think people really learn about it. Even just learning from your doctors, like the true importance of the antibiotics and that you're taking if you have to take any, and following the directions of your doctor as well at taking antibiotics and how to dispose of them properly, stuff like that. So I think just more education earlier on, so people like me just learning about that's cool.
Do you ever get the chance to talk to folk now that you're known to be working on this within your like friends and family circles? When you talk to them about it, what does it feel like hooks them in the AMR discussion? Or does it? Are they not interested in your work at all?
I would say my family, I feel like they still aren't super interested, or they just don't completely understand it yet. I have a lot of friends who are in med school, so they understand what AMR is, but then, not understanding how it is in the environment, I guess, is the one thing that they're kind of curious about, which, I'm happy to always talk to them about it if they do have questions. And that's one thing about this project is like we kind of still don't really know how it being in our water affects our human health, so that's just, it's something that we're concerned about, but don't really know what it's doing quite yet. And that's what the risk assessment, part of this project is going to help us out with as well. Yeah,
I think Dr. Bing Wang is the one who's doing that part of the project. Yeah.
Right. Yes.
And we have had her on the podcast before, so maybe when we get this one up, we'll link to that. And even though it's not on this project that she was interviewed before, there's general principles, and then maybe we can get her on again to talk about the results from here when she gets them. It's always interesting. Another opportunity to like with the computer modeling, where you're like putting everything together and trying to see what the real world implications are within the landscape. The risk assessment modeling is kind of similar, where it's like, what is the real world implications for health? Like the actual scale of the threat once you've taken all of these factors into account. Right. So it's always interesting to see those kind of like final results. A lot of our scientific results are like, the nitrate was significantly different under this treatment than that treatment, and everyone was like, nobody cares. So what does that mean? But when you're able to like put it all together in these big models and show someone like for a landscape scale, like what does it mean for the concentration of chemicals in the stream that runs through your property, or for the human health side, for having those chemicals there, what does it mean for your health? And that's where we can get real. My hope is that is going to really convince people that AMR is important once we can put some data to all of our little conclusion, or not some data, some meaning to all of our data, I guess.
Yeah.
All right. Well, we want to thank Moriah for joining us today, but we really appreciate you taking the time to chat with us for a while in this shaggy kind of way that it was. We haven't done one of these for a while, so we're a little out of practice. And good luck with the research and the career and saving the world from AMR and environmental contaminants and all that stuff. So